Now here we're going to figure out how to deal with different combinations of resistors. So we have this more complicated circuit with 4 resistors, but they're not all in series or all in parallel, okay? Because you don't just go through and there's no branches. It branches right here, but it's not all separate branches. So you have to kind of figure out what's going on. Well, and we break it down piece by piece. So where does current go? Well, it goes out of the battery. It would pass through R1. Then after R1, it's going to split and go down these 2 branches. Some's going to go through R2, some's going to go through R3. Then what happens? Well, then it recombines over here and then passes through R4, back through the battery, back through R1. Okay? So we look, okay, current goes straight from the battery to R1. So R1 is in series with something, but then it splits. So here we got 2 different branches. So R2 and R3 are in parallel with each other. So we can say the resistance of the combination of 2 and 3 is equal to 1 over R2 plus 1 over R3, because they are in parallel with each other, right? Now, if we treat R2 and R3 as a single resistor now, which we have done by finding the combined resistance of R2, 3, now we can, you don't have to draw this, but just to help you visualize, now what the circuit has become is this, or this is R1, and this we can think of as being the combination of R2 and 3, and this is R4. Now, these 3 are just in series with one another. All the current goes through R1, then through this combination of 2 and 3, then through 4. So we can say the equivalent resistance of the whole circuit then is R1 plus R2, 3 plus R4, which is R1 plus 1 over R2 plus 1 over R3 plus R4. And we can calculate the equivalent resistance of this whole circuit by breaking it down into pieces and figuring out what's in series with what, what's in parallel with what. Then we can plug in numbers. So R1 is 10, R2 is 15, R3 is 25, and R4 is 20. And then we calculate our way. 10 plus 1 over 15 plus 1 over 25 is 20. I guess that first outer parentheses were unnecessary. And we get a resistance 39.375 ohms. Alright. Now, as usual, for each of these, I would recommend that you pause the video, try to do it yourself, and then watch what I do to see if you got it right. Let's take a look at this. Oop. Look at this. What's going on? Okay. Well, we can worry about the numbers later. We want to find the current passing through the battery. In order to figure out the current passing through the battery, we need to know the equivalent resistance of the circuit, because eventually we're going to say EMF is equal to current through the battery times equivalent resistance. Okay, so we need to figure out what's going on with this circuit. Well, what happens? Current leaves the battery, goes through R1, then after R1 it splits, goes down 2 branches. So this branch is parallel with this branch. But now on this branch, current goes through R3 and then directly through R4. So R3 and R4 are in series with each other, which means if we combine them into one resistor, that would be equal to the sum of those 2 resistances. Now, after we do that, the current reunites down here and then passes on through the battery. So these 2 branches are in parallel with one another because the current splits, and then after it splits, everything's in parallel until it comes back together. So R2 is in parallel with this combination of R3 and R4. So then we can say that the combination of 2, 3, and 4 being in parallel, 1 over that is equal to 1 over R2 plus 1 over R3, 4. And then finally, we get back here, well, the current passes through R1 and then splits. But if now that we've taken 2, 3, 4 as a combination, now it just passes through the combination of 2, 3, and 4. So R1 is in series with the combination of 2, 3, and 4. So the equivalent resistance is R1 plus R2, 3, 4. Okay, and then we can start plugging numbers in. And when you get to complicated circuits, it's probably not worth trying to write one big equation for REQ. Just do it piece by piece. R34 is R3 plus R4, which is 8 plus 15. So R34 is 23. So this is 1 over 30 plus 1 over 23, and then 1 over that to get R234. So R234 is 30. So then 13 point something. So then our equivalent resistance is equal to R1, which is 15, plus R234, which is 13.01, etc., which is just going to be 28.02-ish ohms. And then we want to find the current through the battery. So we use Ohm's law. R EMF is equal to current through the battery times REQ. So 12 equals current battery times 28.02. So we take 12 divided by that, and we find that the current through the battery is about equal to 0.428 amps. So again, we're just breaking down the circuit into pieces to figure out what's in parallel, what's in series with what. This is an interesting one. List all possible equivalent resistances that could be produced by 4 resistors with resistance R. Okay, this is a little bit tricky, but the simplest way these could be arranged is all in series with one another, and then they just add. We get 4R. Then what else could happen? Well, we could have all in parallel. And if they're all in parallel, then you've got 1 over R plus 1 over R plus 1 over R plus 1 over R, which is 4 over R, and take a reciprocal. Okay, so that's R over 4. Okay, what else is possible? Well, we could have 1, 2, we could have 2 in series, 3, we can't have a third one in series without the other one, so we could have 2 in series, then branches off into 2 parallel. So these two together would be 2R, these two together would be R over 2, then they're in series with one another. We've got 2R plus R over 2, which is 5R over 2. Okay, what else could we have? We could have 2 in parallel that are then in series with the other 2 in parallel. Okay, so these 2 in parallel, these each have R over 2. They're in series, so you add them together. So that's a resistance of R. So all in series, 2 in series, 2 in parallel, 2 in parallel together. We could also have 3 in parallel that are then in series with a third one. So this is R over 3, R, add them together, 4R over 3. And there's probably one more combination that I'm not thinking of at the moment. But you could keep listing them out. I think that might be all. I don't know. I hope that's all. I feel like there shouldn't wind up being 5, but if there's another way to combine them, I'm not seeing it. So then these would be all the possible ways to combine. Yes, there is one more possibility, and that is 3 resistors in series with 1 in parallel. Okay, and then you've got a 3R in parallel with an R. So what is that? 1 over 3R plus 1 over R, which would be 4 over 3R, take a reciprocal, 3R over 4. That's the other possibility. And I think that's all the possibilities. I won't ask you to list out all possibilities, just it's an interesting exercise to make you think a little bit. All right. Now, we want to find the power dissipated in this here circuit. And we know power, IV, I squared R, V over R. We don't know the current. We could find it using Ohm's law, but ultimately we're going to need to find the equivalent resistance in order to do anything. So we have to think, how can we break down the circuit piece by piece, see what's going on. Okay. So first, current goes through R1, and then it splits and goes through all the other resistors. So at the end, we're going to say REQ. All the current goes through R1, but then it splits and goes through the combination of the other 4 resistors. So now we got to figure out R2, 3, 4, 5. Well, what's happening? Well, it splits. Current goes through R2, and then current goes through these 3 resistors, and then comes back and reconnects. So that means that R2 is in parallel with that combination. So 2, 3, 4, 5, 1 over that is equal to 1 over R2 plus 1 over R3, 4, 5. And then looking down this branch, current passes through R5, then straight through R3, then straight through R4. So these 3 are in series with one another. So R3, 4, 5 is just R3 plus R4 plus R5. I've got our circuit broken down all the way, and we can start figuring this out. Let's see, R3 is 17, R4 is 35, R5 is 5, so is that 40, 57. So R3, 4, 5 is 57 ohms. Over here, 1 over R2, that's 1 over 10 plus 1 over 57. So 1 over 10 plus 1 over 57, 1 over that, gets us 8.51 ohms. So our 2, 3, 4, 5 is 8.51. So then our equivalent resistance is 10 plus 8.51, which is about 18.51 ohms. Now that we have our equivalent resistance, we can find the power. I'd use the one that has current resistance, voltage and resistance, because we don't have the current. Saves us one step of calculating. So we can say power is, whoops, I forgot a squared when I was writing that formula. It's V squared over R. And our voltage is the EMF of the battery, which I did not give you. Whoops, let's say this is a 12-volt battery. So then the power is 12 squared over 18.51. So 12 squared over answer, and we get that the power dissipated in the circuit is about 7.78 watts. Sorry about that. You would need the voltage, or potentially you could also, be given the current through the battery, but you would need one more piece of information to find the power dissipated in the circuit. Oh, I just realized I have 2 number 17s. Whoops.